Welcome to Qt FasTrack series for API 510 Pressure Vessel Inspection Code, In-Service Inspection, Rating, Repair, and Alteration. In this lecture, we will continue discuss sub-clauses 8.1, Repairs and Alterations, and highlight important information contained sub-clauses 8.1. Permanent repair. Typical permanent repair techniques include the following. Excavating the defect and blend grinding to contour in accordance with API 579-1, ASME-FFS-1, Part 5. Also refer to ASME PCC-2. Article 3.4 for guidance on flaw excavation and weld repair. Excavating a defect and repair welding of the excavation. Replacing a section or the component containing the defect. Weld overlay of corroded area. Adding strip or plate lining to the interior surface. Excavating a defect and repair welding of the excavation. For examples, as per illustrated in the figures, material or weld flaws open to the surface, or embedded flaws are typically removed by a mechanical, abrasive method. For example, as per illustrated in the figures, weld overlay of corroded area. For example, as per illustrated in the figures, adding strip or plate lining to the interior surface. Repairing a crack at a discontinuity. Where stress concentrations are high, for example crack in a nozzle to shell weld, should not be attempted without prior consultation with an engineer. Insert plates. Damaged or corroded shell plates may be repaired by removing a section and replacing it with an insert patch, flush patch, that meets the applicable code. Typical example flush insert is illustrated in the figure. Insert patches may be used if the following requirements are met. Full penetration groove welds are provided. The welds are radiographed in accordance with the applicable construction code. Ultrasonic examination in accordance with ASME Code Case 2235, or ASME Code, Section 8, Division 2, 7.5.5, may be substituted for the radiography, if the NDE procedures are approved by the inspector. All insert plate corners that do not extend to an existing longitudinal or horizontal weld shall be rounded having a 1-inch minimum radius. Weld proximity to existing welds shall be reviewed by the engineer. Filler metal strength for overlay and repairs to existing welds. The filler metal, used for weld repairs to vessel base metal, should have minimum specified tensile strength equal to or greater than the minimum specified tensile strength of the base metal. If a filler metal is used that has a minimum specified tensile strength lower than the minimum specified tensile strength of the base metal, the compatibility of the filler metal chemistry with the base metal chemistry shall be considered regarding weldability and service damage. In addition, all of the following shall be met. The repair thickness shall not be more than 50% of the required thickness of the base metal. This excludes corrosion allowance. As illustrated clear in the figure, the thickness of the repair weld shall be increased by a ratio of minimum specified tensile strength of the base metal and minimum specified tensile of the filler metal used for the repair, where T fill is the thickness of repair weld metal in inches, D is the depth of base metal lost by corrosion and weld preparation in inches, S base is the base metal tensile strength in KSI, S fill is the filler metal tensile strength in KSI. The increased thickness of the repair shall have rounded corners and shall be blended into the base metal using a 3-to-1 taper. The repair shall be made with a minimum of 2 passes. Example: pressure vessel made from ASME SAW 516 grade 70 has a corroded region that will be repaired by welding using a filler metal with that has a minimum specified tensile strength of 60,000 psi. What is the minimum required thickness of the repair weld? If the depth of base metal lost by corrosion and weld preparation is 0.375 inches. Solution example: the given information. Depth of base metal lost D equals 0.375 inches. Minimum specified tensile strength filler metal equals 60,000 psi. ASME S A516 grade 70. From ASME section 9 table QW QB 422. The minimum specified tensile strength of base metal equals 70 ksi or 70,000 psi. Task: determine the minimum required thickness of the repair weld. Solution: as per API 510, minimum required thickness of the repair weld equals depth of base metal lost times ratio of minimum specified tensile strength of the base metal and minimum specified tensile of the filler metal. Plug the given values into formula. So, the answer is C 4.38 in. Repairs to stainless steel weld overlay and cladding. The repair weld procedures to restore removed, corroded, or missing clad or overlay areas shall be reviewed and approved by the engineer and inspector before implementation. For equipment exposed to atomic hydrogen migration in the base metal, these additional factors must be considered by the engineer when developing the repair plan. Outgassing base metal. Hardening of base metal due to welding, grinding, or arc gouging. Preheat and interpass temperature control. PWHT to reduce hardness and restore mechanical properties. These repairs shall be monitored by an inspector to assure compliance to repair requirements. After cooling to ambient temperatures, the repair shall be inspected by the PT method, according to ASME Code, Section 8, Division 1, Appendix 8. For vessels constructed with P3, P4, or P5 base materials, the base metal in the area of repair should also be examined for cracking by the ultrasonic examination in accordance with ASME Code, Section 5, Article 4, Paragraph T 473. This inspection is most appropriately accomplished following a delay of at least 24 hours after completed repairs for alloys that could be affected by delayed cracking. Welding and hot tapping. General. All repair and alteration welding shall be in accordance with the applicable requirements of the ASME Code, or the applicable construction or repair code. Refer to API 582 and API 577 for additional welding considerations. Refer to API 2201 for safety aspects when making on-stream welds, for example during hot tapping. Refer to ASME PCC 2. Article 2.10 for technical guidance for in-service welding. Procedures, qualifications, and records. The repair organization shall use welders and welding procedures that are qualified in accordance with ASME Code, Section 9, or those referenced by the Construction Code. Inspectors shall verify that welders are welding within their ranges qualified on the welding procedure qualifications, and within the ranges on the Specified Welding Procedure Specification (WPS). The repair organization shall maintain records of its qualified welding procedures and its procedure qualification records. These records shall be available to the inspector before the start of welding. Preheating. Preheat temperature used in making welding repairs shall be in accordance with the applicable code and qualified welding procedure. Exceptions shall be approved by the engineer, and will require a new WPS be applied if the exception is a cooler preheat than specified in the current WPS. The inspector should assure that the minimum preheat temperature is measured and maintained. For alternatives to traditional welding preheat, refer to ASME PCC 2, Article 2.8. Post-weld heat treatment (PWHT). PWHT of pressure vessel repairs or alterations should be made using the relevant requirements of the ASME Code, the applicable construction code, or an approved alternative PWHT procedure defined in API 510. For field heat treating of vessels, refer to ASME PCC-2, Article 2.14. Local PWHT. Local PWHT may be substituted for 360 degrees banding on local repairs on all materials, provided that the following precautions are taken and requirements are met. The application is reviewed, and a procedure is developed by an engineer experienced in the appropriate engineering specialties. A preheat of 300 degrees Fahrenheit, 150 degrees Celsius, or higher, as specified by specific welding procedures, is maintained during welding. The required local PWHT temperature shall be maintained, for a distance of not less than 2 times the base metal thickness measured from the toe of the weld. The local PWHT temperature shall be monitored by a suitable number of thermocouples, at least 2. Controlled heat shall be applied to any nozzle or any attachment within the local PWHT area. When PWHT is performed for environmental assisted cracking resistance, a metallurgical review shall be conducted to assess whether the procedure is acceptable. Review questions. Question number 1. Typical permanent repair techniques include all of the following except. Answer is D. Question number 2. When using an insert patch to permanently repair a corrosion region in a pressure vessel, all insert plate corners that do not extend to an existing longitudinal or horizontal weld shall be. Answer is A. Question number 3. Per API 510, insert flush patches may be used under all of the following circumstances except. Answer is D. Question number 4. A pressure vessel made from stainless steel cladding base metal has strength of 17,700 psi and thickness of 0.75 inches has a corroded region that will be repaired by welding using a filler metal with that has a minimum specified tensile strength of 16,600 psi. What is the minimum required thickness of the repair weld if the depth of base metal lost by corrosion and weld preparation is equals 0.25 inches? Answer is C. Question number 5. If a rapier is made on a pressure vessel using a filler material with a lower specified minimum tensile strength than the base metal, all of the following requirements apply except. Answer is C. Question number 6. Who is responsible for reviewing and approving the repair procedures to restore removed, corroded, or missing clad or overlay areas in a pressure vessel? Answer is C. Question number 7. Which of the following is most important when performing weld repairs to a section of stainless steel weld overlay on a carbon steel vessel in hydrogen service? Answer is C. Question number 8. After repair welding a cladded pressure vessel that operates in hydrogen service at elevated temperatures, and after cooling the weld to ambient temperatures, what type of inspection is required? Answer is B. Question number 9. A weld overlay is done for a repair on a vessel fabricated of P5 material. The next day, the base metal, in the repair area, should be examined for cracking by which type of examination? Answer is A. Question number 10. According to API 510, who is responsible for qualifying the welding procedures that will be used during a repair of a pressure vessel? Answer is D. Question number 11. Which of the following is responsible for maintaining the records of qualified WPSs and PQRs used during repairs and alterations? Answer is D. Question number 12. The repair organization shall maintain records of its qualified welding procedures and its welding performance qualifications. What is the responsibility of the repair organization to the inspector regarding these records? Answer is B. This lecture is prepared by Samir Saad, and this is his profile.